So example 1, x plus 10 equals 15. And I know you can probably solve this without using inverse operations, but you want to get in the habit of doing this the right way. So when harder problems approach you, you'll have a method to solve them. So we've got an equal sign. The first thing we want to do is, that equal sign is really the middle part of the equation, even though it's not exactly right in the middle. It is, we're going to treat it that way. So x plus 10 equals 15. To solve for x, we need to do the inverse or opposite operation that's being done to it right now. And right now, a 10 is being added to that x. So to undo that operation, we're going to subtract 10. But we can't just subtract 10 on the left side of that vertical line. We have to do it on the right side as well. So whatever you do to one side of an equation, you have to do to the other. So 10 minus 10, of course, gives us 0. So we're left with x plus 0 equals 15 minus 10 is 5. If you're a mature mathematician, you know that anything plus 0 is just itself. So this ends up just being x equals 5, and that's our solution. You want to get in the habit of checking your solution. So when we take 5 and substitute it back in for x in the original problem, instead of x plus 10 equals 15, we get 5 plus 10 equals 15. And of course, that checks out. Let's do a couple more. The next one is 10 equals b minus 6. So it's a different variable. It's not x this time, it's b. It's the same idea. We'll draw a vertical line right down the middle. And we're subtracting 6 from b. Remember, our goal is to isolate the variable, which in this case is b. So we're subtracting 6 from b. So the inverse operation of a subtract 6 is we're going to add 6. We're only going to add it to the constant. We're not going to add it to the variable because those are unlike terms. So we add 6 to both sides. On the left side, 10 plus 6 gives us 16. On the right side, we get b. Negative 6 plus 6 is 0. And at this point, you can probably stop writing the 0. And we end up getting our answer of 16. Let's double check it. And 10 equals not b minus 6, but we want to take our solution 16 and substitute it for b. 16 minus 6 is 10. 10 does equal 10, so that solution checks out. The next one, 4k equals 12. A habit that might be helpful for some of you, because students really struggle with this. When the number and a variable are pushed together like that, that means multiplication. So I'm going to put a multiplication dot there between the 4 and the k. A lot of people see that positive 4 and they think, oh, we just need to subtract 4 from both sides. That's not the case. This is 4 times k equals 12. So we have to do the inverse operation of multiply by 4, which, remember, the inverse operation of multiplication is division. So we're going to divide both sides by 4. We're going to use this fraction bar instead of the division symbol to simplify this. 4 divided by 4. What is 4 divided by 4? That's 1. So we get 1 times k equals 12 divided by 4, which is 3. We don't really need to write the 1. So a mature mathematician knows 1 times k is really just k. There's an assumed 1 in front. Equals 3. And let's just double check the math. Instead of 4 times k equals 12, we're doing 4 times 3 equals 12, and 4 times 3 is 12. Our last one, b divided by 3 equals 5. Just a side note, sometimes you may see this written as 1/3 times b equals 5. I'm not going to write it that way, but just know that those mean the same thing. Because remember, there's an assumed 1 in front of that b. So we're dividing b by 3, so we need to do the inverse operation. Instead of dividing by 3, we're going to multiply. Specifically, we're going to multiply this numerator by 3. And whatever we do to one side, we have to do to the other. So on this side, we get 3 times b at the top, divided by 3 at the bottom. On the right side, we get 5 times 3, which is 15. 3 divided by 3 is just 1. So 1 times b equals 15. Mature mathematicians know we don't need the 1 out front, so 15 is our answer. Now let's just double check it. Instead of b divided by 3, we're going to take our answer for b, which is 15, and divide it by 3 to see if it gives us 5, and it does. 15 divided by 3 is 5. Try this last one on your own. 6x equals negative 24. Remember, the goal is to isolate the x in this problem. So try it on your own, see what you do. I'm going to give the answer here in about 5 seconds. 3, 2, 1. So there's my work, and there's my answer. I got an answer of x equals negative 4. And of course, when I take negative 4 and substitute it back in for x, 6 times negative 4, a positive times a negative, gives us a negative. So negative 4 is the solution.